Okay, so in surveying, we're always talking about a traverse, which is a closed loop. Why in surveying do we want to start and end at the same point?
Because we know the exact location.
Okay, we'll know information about that first point, right? Maybe we might know its north and east coordinate, which is horizontal control. Maybe we'll know its elevation. But if we start at one point and come back to that point, we can check ourselves. And surveying is all about measurements. We want to make sure that we can check ourselves. So a closed loop is called a traverse. Uh-oh. It's an S. Okay, so in this particular example, we're looking at a traverse, right? It's a closed loop. So I think this is pretty explanatory that these are considered interior angles and these are exterior angles. So those are two types of horizontal angles. Let me just number them. Here's one, here's two. So there's one type of horizontal angle is an interior, one is an exterior. Okay, third one. Let's take a look at this. They're calling angle to the right, and there's also angle to the left. So what happens? Right here at C is where I have my equipment set up. And I sight B. And then I turn my equipment, and then I sight D. I'm turning to the right? We might say we're going clockwise, right? But in surveying, we tend to call it going to the right. What if I did, so when I sight that corner of the room and then I turn to this corner of the room, I'm measuring an angle to the right. If I sight this corner of the room and then I turn this way to this corner, I am measuring an angle to the left. So interior, exterior, angle to the right, angle to the left. Oops, 3, 4. Does everybody understand that? That my equipment is set up at C, I sighted B, and I turned and sighted B. Okay, let's take a look at this. Now my equipment is at B. Equipment's at B. What is this dashed line here? It's an extension of line AB, right? Just keeps going. Does everybody see that? Same thing here. If I have my equipment set up here at B, this dashed line here represents the extension of line AB. What's really cool with surveying equipment? Now with the level, because a level really can only be level. You can't turn it. But if you, I don't know if you touched the total station that we had out in the theodolite, you could actually spin it. There's a telescope on top, right? It's connected here and you can just spin it around. Well, it's got to move because you got to be able to take a vertical angle, right? Measure a vertical angle. But let's say I was set up, let's do the first one. I'm set up on B. There's A. So I'm sighting A. I could turn the telescope. And now I just went 180 degrees. So I could sight A and turn, keep looking, and make sure I'm reading it, that I went 180 degrees. Or I could take the telescope and just flip it, and I'm 180 degrees. So if there is a line from A to B, and I flip it, didn't I just extend line AB? Right, so in both these cases, I was set up on B, I sighted A, and I flipped the telescope, and now I'm looking here. Then I could sight C. This right here is called a deflection angle. This is the same. I'm set up at B, I sight A, I flip the telescope, and I turn to C. Now, we know this angle here is 180, right? So how would we find this angle? Subtract this from 180. What does this R stand for, and what's this L stand for? Angle to the right, angle to the left. Because once I flipped it, I then turned to right. Here I flipped it and I turned it to the left. But the key thing you want to know is, fifth type of horizontal angle is a deflection angle. So I'm pretty sure in geometry or some kind of math that you've taken in the past, you've heard people refer to as these angles as interior and exterior. So you've already seen this. This, you didn't know there was an angle to the right, but I'm imagining that you did turn your angle, right? You didn't measure an angle, but you did turn it, right? When you were looking at the level, and then you took a back sight, and then you took a fore sight, you actually did turn it. Physically, you already did it turning. And we tend to work in clockwise, so which one is the more popular one to use? Angle to the left or the right? Right, turning to the right, okay? And then this is something different. And you're gonna experience it as we go along. Okay, the next two. So now, I'm gonna erase this. Although all those exist, the most popular are bearings and azimuths. Does everybody see my little symbol here for angles? Okay? So important, there are three pieces of information you need in describing an angle. You first need to know what the reference is. So in the example I said where I'm sighting that corner of the room, the line rather, from where I am to that point, that corner, that's my reference, that's my line of reference. Does everybody agree with me? Like if I want to measure a horizontal angle or a vertical angle, I have to have a line of reference. So if I'm trying to measure this angle here, if I drew a line from me to the corner there, that's my reference line. And then I want to turn it to the right. So the next thing is the direction. And the last one is the numerical value. Okay, let's look at bearings first. Let's look at azimuths first. So for azimuths, the reference is north. South only if stated. So let's draw a north, south, east, west line. North, south, east, west. And let's say up. This is my line. And let's say this is 50 degrees here. So what's the angle here? What's that? 40. There will be times, I know you know this is 90 degrees, but there'll be times by accident you'll subtract from 100. Maybe because you're always dealing in $100 bills. So always check yourself. Do 90, okay? So for azimuths, our reference is always north. Our direction is always clockwise. So we always go clockwise. And then whatever the angle happens to be, the number. So let's try it on this example. So the reference on an azimuth, so what you're doing here, both of these are describing, you're describing a line. So the line we're describing right now is this blue line. So for an azimuth, what's the line of reference? North, so first you're north. And then the direction is you always move clockwise, right? So we're moving clockwise until we hit the blue line. And what is the angle here? 90 plus 40, so it'd be 130 degrees. That's it. The azimuth of this line, the azimuth is 130 degrees. Let me erase it here. What's the azimuth of that line? Your reference is north. You always measure going clockwise, so what is it? 345. That's the azimuth.
So subtract?
So what you could say you subtracted, but basically what you did is you went all the way around. You had to go all the way around to hit this. So in a way, it's 360 minus 15. Okay, how about this one? What's the azimuth here? Hmm? 200. And it's 180 plus 20. So azimuths are used, they're an angle, they're a horizontal angle used to describe a line. The first line is this line right here. And that line had an azimuth of 90 plus 40, 130. This line right here has an azimuth of 180 plus 20, 200. This line has an azimuth of 360 minus 15, 345. Everybody got it? Now I did say that sometimes the reference south is used, but it's got to tell you that it's the south azimuth. But the clockwise direction is still the same. So if we were using, and in this class we're never going to use south azimuth because it's not something that's common. But if we did use the south azimuth, where would my reference would be here, right? And I'm still going clockwise, so what would be the south azimuth of this? 20 degrees. What would be the south azimuth of this? 165. So should I write that down? So if you just say azimuth, it's always the north. But if you say the south azimuth, would be 20 degrees. Here, the south azimuth. What's the south azimuth of this one? 310. Because you have to go all the way around. So it's 360 minus 50. And what's the south azimuth of this one? Of this guy? 180 minus 15, so 165. Okay, everybody good? Okay, let's look at bearings now. So for bearings, yeah. The reference is either north or south, and the direction is either east or west. And then the numerical value, actually, let's talk about this. The value numerical value for the angle? Could there be an azimuth of 0? If there's an azimuth of 0, it's just north, right? An azimuth of 360 is north, right? So our angles for an azimuth can go from 0 to 360. I probably would never say 60 though, right? So maybe, let's say this. Let's say the angle is equal to or greater than 0, and it's less than 360. Does that make sense? Do you understand my notation here? So the angle, the azimuth angle can be 0, but it's not 360, because if it was 360, it would just be 0. Here, the numerical value of the angle can be, well, if the angle is 0, it's north. If the angle is, oh boy, let's see. It's greater than 0 and less than 90. This is it. So the angle value could go from 0, is everybody okay with this symbol? Should I, put like an alpha or something? No, what theta, I think. Is that better? So the angles can only go from 0 to 90. It has to be greater than 0 or less than 90. So let's have an example. North, south, east, west. Just like azimuths, they're horizontal angles that are used to describe a line. It's the same thing. A bearing is a horizontal angle, a type of horizontal angle used to describe a line. So let's put, let's say 30 degrees. So where azimuths are always measured from the north, bearings, they can be measured from the north or the south. So looking at where this line is, would you measure it from the north or from the south? North. So this line is going to have a north. The direction it's going in, direction, is the direction of this line going towards the east or going towards the west?
East.
It's going towards the east. And how many degrees did it go towards the east from north? 30 degrees. So it's north, 30 degrees east. North is what? The reference. The direction it's going in is east. And then you put the angle from the north.
That's the notation, that's how you write it.
That's how you write it. So let's say we had this one that's 50 degrees. What would this bearing be? Is it coming from the north or coming from the south? Remember, the angle could only be between 0 and 90. So is it closer to the north or the south? North. Is it going east or west? Actually, can we change this? I'm going to put the 50 degrees here. Everybody change that? Where I put the 50 degrees? So it's reference from the north. Is it going towards east or west? And how many degrees is it going towards the west? 40 degrees. Because the angle is from the line, the reference line. So let's try this. The bearing, north or south? East or west? How many degrees? 20. How about this one, north or south? East or west? How many degrees? 60. So talk to the person next to you and make sure you both understand the difference between these. Both azimuths and bearings are angles, horizontal angles that describe a line, but they have different, so describe the difference to the person next to you.
I'm mostly curious on why you would use one over the other. But I guess, I mean, obviously with bearings, you can be a little bit more specific, whereas obviously if you're using azimuth and you have to go all the way around, so maybe it's speed related?
I don't think it's speed related.
No?
I think it's just by convention.
Really?
Yeah, I've heard a lot of like navigation, land navigation is done with like azimuths.
Oh, really?
Yeah.
Okay.
And bearings are used a lot in like boat navigation, ship navigation.
Okay.
And azimuth.
I'm not sure
Okay,
that.
this is
I'm
a
not
good
sure why,
question.
but
So
I've seen
Mason
them.
Fair
said,
enough.
how do you know if you're given an azimuth or a bearing? How it's written. An azimuth is only an angle reading. That's it. Only your angle reading. But a bearing has what? A north or south at front, an east or west at the bottom, I mean on the back, and then a number. Okay. I'm going to cover this up. So let's look at Francisco, is your hand up?
Yeah,
What's up?
so like, if it was like north 90 west, it could also be south
If it's
90
no,
west.
it can't be north, it's a great question. Can it be north 90 west?
It can't be like 90.
It can't be 90,
Okay.
right? It has to be less
Yeah,
than 90.
okay.
So if it's north 90 west,
Yeah.
it's really west,
West, okay.
okay? So there's a constraint. Here, the value can go from 0 to 360. It could be 0, it can't be 360.
So then with bearings, you would just say west?
You would just say west.
Oh,
You would just say west.
west or-
Where, so if a line is going to the west with a bearing, you would just say west. But with the azimuth, you would say, if a line is going west, what would its azimuth be? 270. Okay, so let's take a look at this for a minute. You notice that each line on the edge of the property is described by an angle and a distance. What kind of angle is that? A bearing. It starts with north or south, and it ends in the east. Okay? Okay, so now, let's, here are some examples. So here's one. So what page is this, 24? 30, okay. So 30 for you guys. Oh, that's true, because I pulled the homeworks out when I was getting a little crazy with the website. I realized I had homeworks posted one place, why did I put the homeworks in the packet? So I pulled them out. That's okay, we'll figure it. It'll cause us to talk a little more in class. Okay, so what I want you to figure out now is I want to know, let's do azimuths first. Do the azimuth from A to C, A to E, A to D, A to B. Can I erase the whiteboard so we can do it right on here? Yeah. Okay, so I'm going to make a little box here. So going from A to B, going to A to C, A to D, A to E, what is the azimuth? And then, I wanna know what the azimuth is going now. First, we're looking at going from A to B, and A to C, and A to E, and A to D, and now I wanna know what is the azimuth going from B to A, and C to A, and E to A, and D to A. So this is the green arrow, and this is the red arrow. Do you have them yet? Yeah, Mason.
Back to the question that I previously asked, what keeps this from being a variant? Because like you aren't given.
Oh, so right now, I drew lines up there, right? And
Yeah.
I'm asking you to tell me what the azimuth is. In a little bit, I'm gonna ask you what the bearings are too, but right now I only wanna know the azimuth.
So for like an equation on homework, it would say like
We say find the bearing or find the azimuth, or find both, yes.
that's how you would know whether or not.
That's how you would know which one to give me,
Okay.
yeah.
That was what I was trying to figure out.
Okay. Francisco, what'd you get for AB? So what's, for azimuth, what's the reference?
It's north and then you go to the right,
Then you go clockwise.
so it'd be 304.
Yep. Right, here's line A to B. You start at north and you gotta turn to the right. You gotta go all the way around this way to get to that. So it's 270 plus 34. Logan, question?
The first part totally made sense, but
Okay, so let's, maybe there's just too many lines
what's
in there
more
now.
just, so if you're starting at A and it's not the north
So
reference.
let's get rid of this, right? And this right here, right, this point right here is point A. Right? So
So
I'm
basically
going,
our north.
I'm going from A to B, and here's my north, south, east, west. So sorry, the A is kind of up there, this is A.
Okay.
So I'm A to B, so I'm starting at north and I'm swinging around, so it's 270 plus 34. Okay, Logan, how about the next one, what's A to C?
50.
Right. David, how about A to D?
197.
Okay, so let's see, it's 270 minus 73, or we could say 180 plus 17, right? 180 plus 17. Did you say 197? Good. Maybe I should show, so this one has, this one is 90 minus 40, which is 50 degrees, and AB would be 270 plus 34. 294, 304. Is that helpful for me to show you the math, how I'm getting it, okay? Okay, how about AE? Yeah, Rylan?
I'm still confused on the second part, from
Yeah.
B to A.
Yeah.
Oh, we didn't get there yet.
What's
Well,
the difference?
Okay, I'll show you in a little bit. Okay, so Ruby, you wanna do AE?
149.
Yeah, how'd you get it?
I did 90 plus 59.
Right, so everybody's okay with these? Okay, now let's look at this. So now, instead of looking at A to B, I'm looking at B to A. Here's B and here's A. So really what we're gonna probably wanna do is do an extension. If we know this is 34 here, if this is 34, this right here is 34. And we're really going this way. So it's like it's coming down here, explaining it one way. Now I'm gonna explain it a different way, because I don't like that way. This is what I do. Here's B, here's A, and my arrow is going like this. What I always do is I always draw my coordinate system at the tail. North, south, east, west. You'd all agree that going from A to C is no problem because this is where my grid is, my north, south, east, west grid. So I can figure out the angles. If I'm going from B to A, I always draw my grid here, and if this here is 34 degrees, that means what's 34? This right here is 34 degrees.
But you just, with the last example said, beneath the line was 34. Like,
No, when I went like this,
yeah.
I said this was 34.
No, you
No,
messed
you
up.
put it.
Oh, I messed up? Oh, okay.
Yeah.
Okay, thanks. Wow, good thing well, not good that I erased that. Okay, so sorry. So now, you know your azimuth starts at north, you're turning, so what is BA gonna be? 90 plus 34, right? 124 degrees. Good? So I guess that's maybe why I always draw my grid at the tail, because I mess up at the vertical angle. Okay, so now going A to C, now I'm going from C, oops. I'm going C to A, right? And I'm gonna draw my axis, north, south, east, west. This right here is 40 degrees, right? So this right here is 40 degrees, is that right? So what's the azimuth? Julio. So the reference, you have this, right? So this is 40 degrees right here, see the arrow? This is 40 degrees, so that means this is 40 degrees. My reference is always from north. I'm turning clockwise because that's the direction. And what does my angle wind up being? What's my azimuth?
30?
Okay, so let's see, I would say, yeah, I would do 270 minus 40, so it's 230. Kevin, okay? Okay, Kevin, how about the next one? So DA, here is D to A. Here's the angle of 73. I'm going to draw my axes. If that's 73 right there, then this right here is 73. North, south, east, west.
17.
17, so it's 90 minus 73, which is 17. Okay, Ty, how about the last one? We're going.
I'm never lost.
You are? Okay. Okay, so here, let's do we know right now, here's my east line, right? Well, let's do it in a different color. Here's my east line, right? I'm so glad I called on you because you wouldn't have said that you were lost. But I called on you. Here's my east line, here's my south line, right? Okay. Here is, this is 59 right here, right? So we're going from E to A. Here's E to A. And I'm going to draw my coordinate axis at the tail. North, south, east, west. If this is 59, this right here is 59. So far, so good, right?
It should be the other angle,
You got it again.
Oh, yeah.
the west, to the west of it, yeah.
Shoot. looked small.
Northwest.
Thank you. Okay, so now, this line is the one in question, we're coming from the north, so we're going all the way around, that's 90, 180, 270 plus 59. 270 plus 59, and what's that? 329.
Okay.
Okay, I'm gonna erase all this. Okay, now we want to do bearings. Oh, let's just look at this for a minute. Well, no, we'll come back. I'll remind me I want to look at something else. So for bearings, what's the line of reference? Either north or south. The direction is east or west, and the number has to be less than 90. So why don't you do some first, and then I'll go around. Patrick, are these all the tools? There are more?
There should be, I think, some on that
Yeah,
side.
in a little bit.
I got it. This side, Oh,
These are the doors. They're plastically deformed. Okay, ready? Okay, Jameson, what's the bearing of A to B? A to B.
North, 56 degrees
Okay, north, not south. Is it east or west?
east.
Going from A to B. Going from A to B, west. And then what's the angle?
56.
Great. Luika, next one. Going from A to C.
North 50 east.
Okay, north, and it's east, and it's 50 degrees. Why is it 50 degrees and not 40? You started north as the reference. Okay, how about AD? Basin? From A to D. North or south?
South,
East or west?
west,
South, what'd you say, east or west?
west,
Okay, and how many degrees?
17.
Right. I think you guys like bearings better, huh?
Yeah.
Okay, Peter,
Yes.
A to E. North or south?
South,
East or west?
east.
Right, because it's going towards the east.
Wait, no.
Because the line is first south, right? You chose south.
Yeah.
You want to go the direction in the east, so this is the angle here. 31? Right, because it's 90 minus 59? 31. Okay, so now just what we did before, we're doing the same thing. So now we're looking at B to A. Here's B to A. Here's my north, south, east, west line coordinate system. This is 34, right? So this is 34. So Tristan, B to A, north or south,
South,
east or west,
east,
and how many degrees? Say it again?
56.
56. Okay, C to A, here's line CA. I draw my coordinate system, north, south, east, west. This is 40, here's 40, so this is 40. Alan, north or south?
South.
East or west? Right, how many degrees? Yeah, 50 degrees. Okay, DA. Here's DA. I draw my coordinate system. This is 73, so that means this is 73. Rylan, north or south?
North.
East or west?
East.
How many degrees?
17.
17. Mason, did you go already?
Yeah.
Okay. So Ruby, I got everybody here, right? Tristan, did I get you?
Yeah.
Ruby,
Um,
so EA, here's EA. North, south, east, west. This is 59, so this is 59. North or south?
north,
East or west?
west,
How many degrees? 31. So Julio, what do you notice between the forward and the back bearings? The bearing of AB versus the bearing of BA? What do you notice? Does it look, oops.
The north and the south, they're the opposite.
Right, the north and south are opposite, the east and west are opposite, but the numbers are the same. So, if I give you a problem where I say I want the forward and the back, is it a good idea to do the forward and then just make it opposite? No. You do the forward, you do the back, and then you compare them to make sure that they're the same, because you want to do a check. So how about the AC and CA? Is it checked? AD, DA, yes. AE, EA, and checked. Okay, now what about the azimuths? Is there anything that makes them similar? No. They're off by 180, but you don't know whether to add them or subtract them. Right? The difference between 304 and 124 is 180. The difference between 50 and 230 is 180. The difference between 197 and 17 is 180. And the difference between 149 and 329 is 180. So there is a difference of 180, but it doesn't have to be a positive or a negative.
Find that depending on if it would be greater than 360 or less than 360.
No, because if I add 360, if I add 180 to this, once I hit 360, it's 0.
Yeah,
Would that be right?
yeah.
It's 329. So if we take, sorry, if I take, okay, we're at 329, add 180, and then subtract 360, we get 149. 124 plus 180, 304 plus 180 equals minus 360. Okay. So I guess it could work. Everybody see what we're doing? If you take 149 and you add 180 to it, you get 329. If you add 180 to 329, it puts you over 360, you subtract 360 and you get 149. So yeah, I guess that makes sense because you're off 180. Right? Pointing this direction, that one. Okay, are you getting a little comfortable with doing azimuths and bearings? These are the ones that are most popular. So then the next question, look at the next problem below it. Should I not pull it? Oh, Francisco, is that you? Is it okay that I put this down?
that's fine.
Okay, so now we have a line that goes from A to B. We have a line from B to C. We have a line from C to D. So I want to know what is the bearing and azimuth going from A to B, bearing and azimuth from B to C, bearing and azimuth from C to D, and then backwards. And I'll set it up over here. Look at that. Cut it out.